Good afternoon, everybody. Welcome to our third lesson on human impact on the environment. Today, we're going to be talking a little bit about technology and industrialization, how some of the technology and the things that we have created as humans to advance our civilization, how they have had some of the negative impacts on the environment, and some of the things that we're going to try to do, or hopefully try to do in the future to change that. Right. Humans have been using tools and machinery to make things for thousands and thousands of years. As technology advanced, humans have been able to create factories in order to make things that people want. These factories, these places, these advances in technology have changed the environment. They've committed pollution, destroyed the environment, and just for human advancement. Right? So the first thing we're going to look at is the different ways that energy has been made. Right, there we go, there's my pen. We've been making energy using fossil fuels for a very, very long time. But fossil fuels, as we have learned, they really negatively impact the environment. They burn dirty. They are a non-renewable resource, so they're going to run out eventually. There are cleaner ways to make electricity. There are cleaner ways of making energy. And we have only relatively recently started looking into those and started doing more environmentally conscious methods of producing energy. And every type of energy has its pros and its cons, and we're going to break those down. Right. Fossil fuels are our main source of energy. That's our coal, our oil. The advantages can be used anywhere, can be used anytime. Their disadvantages, they're non-renewable. They are going to run out, and they cause lots and lots of pollution. They cause air pollution. They cause water pollution, acid rain, greenhouse effect. Right? All these things are things that we're going to talk about. Nuclear energy, the main advantage of nuclear energy is that there's no carbon dioxide given off. There are huge amounts of energy to be harvested, I suppose, from nuclear power plants. But the downside is that there are radiation issues that can happen. There's dangerous wastes, and there's heat pollution. And so nuclear power plants run very, very hot, and you need to counteract that if you want a successful power plant. Water, wind, and solar are our our renewable energy sources. Right, water energy. Right, so things like hydroelectric power plants, those have no pollution. They are renewable, but they are limited in the places you can create them. Right, you can only put a water-based power plant near a body of water. A running body of water. Going back for a second. Heat pollution. Atticus, heat pollution is when you generate excess heat. So, for example, if you've ever had a laptop on your lap and you feel the back of it get hotter and hotter and hotter and hotter, that is heat pollution. If you take that and you scale it up to the size of a factory, right? Heat pollution is when you have this huge quantity of heat that you're making with nowhere to go. So in nuclear power plants, they have these big vats of water, and they basically just water cool the nuclear energy production. So this water here acts as a place for all of the heat to go into, but it still needs somewhere else to go after that. It just raises the temperature of the surrounding area in the environment. So that's heat pollution. Right? Anytime there's excess heat. The same way that you could talk about light pollution anytime that there's excess light. Right? That's why it's really hard to see the stars in New York City, is because there's so many lights that it blocks out the view. That's why like observatories are built far away from like cities and towns and they have very little lights surrounding them, is because light pollution prevents you from seeing out into space. When we talk about wind energy, right, there's no pollution in wind energy. It is renewable, but if it's not a windy day, you're not going to generate any energy. Right? You need that wind to be blowing if you want your windmills and your wind gatherers to actually work. Solar energy, it's renewable. There's a little bit of pollution. There's heat pollution because it is, again, soaking up that sun. But it's only available on sunny days or areas without a lot of cloud coverage. So there are these downsides, these limitations to our renewable sources of energy that fossil fuels doesn't really have, which is why we've, not really the only reason why, there's plenty of other reasons why, but this is why fossil fuels have remained the dominant source of energy for so long. It's not that windmills aren't efficient. Windmills are great, and they really can get lots of energy, and they can replace a power plant, but if the wind stops blowing, they stop working. And that's not true of, like burning oil or burning coal. You burn it until it runs out. But if I spend the people don't want to spend a lot of money to build a windmill and then have it not work because the wind isn't blowing. It's not that wind energy is less efficient. It's just it's less predictable. Whereas I know if I burn this oil, it will last until this oil runs out. And if I see the oil getting low, I know I can go and refill it. But there's no way to refill the wind. There's no way to tell ahead of time, like, oh, on Wednesday, it's not going to be that windy. Right? So without that knowledge, we can't, guarantee that a windmill is going to produce energy constantly. I don't think you're using efficient correctly. I think it's less reliable, but efficiency is based on how much energy is produced when the wind blows. Right? How much energy is produced when the water is running? How much energy is produced when the oil burns? Right? The amount of energy that you make is connected to the efficiency. Right? And when the wind is blowing, windmills are efficient. They make lots of energy. But they are not 100% reliable because the wind doesn't operate 100% of the time. Right? You could have a less windy day. Does that make sense? I'm trying to differentiate between the two here. All right, great. All right, so we're going to look at a little bit of how these, right, we're really caught up in fossil fuels, right? We're always, right, our cars are still gasoline based, right? We're not all in electric cars. We're not all in hybrid cars. It depends, right? So are they worth it? Yes. Should they be the only source of energy? No. Right? Something we'll talk about is that if you can combine your renewable energy sources, right? If you can have a wind farm and something near running water and something that like a solar farm, you can kind of cancel out these downsides, right? If I have a wind farm and a solar farm, right, then when the wind's not blowing, the sun is shining, or when the sun isn't shining, the wind is blowing. Right, so it's by itself a little less worth it, but that's why you see a lot of them crop up, right? Wind and solar farms crop up in kind of pairs, right? Because if you can get them both, when one doesn't work, the other does. Right, so they can be. They are often, sorry, they're often used. They're often placed in areas that have fewer animals, if possible. But that is another thing that has to be taken into account, right? Like building a big giant solar farm in the desert is going to interrupt that desert ecosystem. And that's one of, we'll talk about this later, is like weighing our choices. Is it worth it to disrupt the desert ecosystem if it means that we won't be using as many fossil fuels, right? If we can get the entire country to run on clean energy, is it worth it for, that sacrifice we have to make, right? We have to balance our pros and our cons, our effects and our harm. But a lot of the time they aim, right, when you build a power plant, they aim to replace an older one. So the idea is like taking a defunct factory or taking a defunct plant, something that it hasn't been working or isn't working, and replacing it with something a little cleaner. Industrialization is what we use to talk about factories and building industry. There's positives and negatives, right? The big positive is that it allows people to get what they want and what they need, whether that's food or furniture or construction materials. The downside is that they use up resources, they mess up habitats, they pollute the air, they pollute the water, they pollute the soil. So a lot of industrial factories, a lot of places that are big in industry have to really be careful about the way they conduct themselves. Because if they, aren't careful, they will really hurt the environment and impact the planet. And we're going to talk a lot about these types of pollution that we're going to see as we continue. Air pollution is a really big one. If you have a factory, you're burning off some of the fossil fuels that you're using to run it. You're producing carbon dioxide, sulfur, or nitrogen, right? Making these gases and putting them into the air, and affecting our gas transfer, right? Our plants taking in the CO2, giving off the O2, and then us taking in the O2 and giving off the CO2. If we add more and more and more CO2, if we add more and more and more CO2, we throw off the balance of this gas transfer and we overwhelm the plants and we make CO2 faster than the plants can filter it out of the air. All right. Smog is the word that we use for big clouds of air pollution, right? When we have, exhaust running all day, when we have factories producing these chemicals, the sunlight will react with them to create gases like sulfur dioxide, make nitrogen gas, and our favorite CO2, which is harmful to living things, including the trees, right? Sulfur is not super great for plants or animals to be breathing in. And so when we have these areas of the world that are really smoggy, one of the big ones being in China, you see that a lot with the factories and how they produce all of this gas, and everyone goes around wearing masks and people stay in a lot of the time because of all of this pollution, all of this smog in the air. When we talk about acid rain, those same chemicals that we have when we talk about sulfur and nitrogen, when it rains, they react with the water and it turns the rain acidic. And then by having this acidic rain fall on places, it messes up the pH of the water. So if you have a lake that's being acid rained on, it'll lower the pH of the lake, affecting the animals that live in that lake. If it falls in the soil, it'll affect the pH of the soil, affecting the organisms that live in that soil, right? The plants and the bacteria. If you have it fall onto stone structures, right, or buildings, right, you've seen marble statues fade away because of their acid rain components. It's all because of the sulfur reacting with the water. So if you have SO2 plus the water, you're going to get H2SO4, right, forming, which is an acid, and that's going to then fall on things and affect it, right? It'll help kill trees. It'll help kill fish in the lake. It'll kill plant life in the water because by lowering that pH, making it uninhabitable for these types of organisms. There are ways to filter out sulfur and nitrogen compounds from the exhaust. If you have a factory stack that's blowing out all of this pollution, there are machines and filters that can be placed inside these factory stacks or even lower down in the factory itself to catch the sulfur and nitrogen that's coming out and prevent it from coming out, and reducing that effect on the environment, right? Preventing some of this acid rain, preventing some of this air pollution. We look at global warming in general. It's having to do with the carbon dioxide in the atmosphere. It causes the greenhouse effect, which we'll talk about in a little bit. But it is raising the temperature of the planet, and the hotter it gets, the more we find ourselves shifting away from animals that can live in colder places, disrupting things like the ice caps, changing the amount of water that is in rivers and lakes, right? Either evaporating lakes or flooding them with the melted ice cap water. We have things like the ocean levels rising because of the extra water being taken from the melting ice caps. And there's ways to get around that, right? We need to filter out carbon dioxide from the air, which means we need more plants, more things to take in that carbon dioxide and get it out of the atmosphere. We need to use cleaner energy to prevent that carbon dioxide from entering the atmosphere in the first place, to help us keep the planet at a reasonable living temperature. The hotter the planet gets, the harder it is for animals to live in it. The biggest thing to be affected by this are Arctic animals. Things like polar bears, who can only live in these colder environments, things like penguins and other Arctic seals that have adapted over thousands of years to live in this environment. If that environment goes away, they will not survive. And even then, if it got consistently, if it just got 5 degrees hotter every day all year round, there wouldn't be enough cool temperatures to help balance out the animals that need them, right? So think of animals that have heavy fur. If it's just hotter and hotter and hotter, they're going to get cooked inside their own fur here. And so it's really important that we try our best to reduce global warming. Ozone depletion is another thing that is going to affect global warming. The ozone layer helped by bouncing away some of the radiation from the sun, right? So some of it gets in, but some of it gets bounced away. but the more and more we disrupt the ozone layer, the more and more that we pollute and damage this protective shield that we have, the more and more radiation gets into our atmosphere. Right, and then we're going to look at the greenhouse effect in a second, but the combination of more carbon dioxide and less ozone is cooking us from the inside out. Right, is that our next slide? Yes, good. So, the greenhouse effect. I'm going to get to draw a little bit here. We have our planet. Our beautiful planet Earth. Right, sort of blue, sort of green, which I'll get to in a second. Our planet has some protective layers, mainly the ozone layer. Those are our big defense from the rays of the sun. Right? The fact that we have been polluting the planet has made it really difficult for the planet to stay healthy. What's a general North American shape? Let's give us some of that, some of this, some of that, and put Mexico down there, South America. Good enough. Don't forget Greenland. Can't forget Greenland. Right, our protective layer came from our atmosphere. We have... I don't know why I started talking about the atmosphere without drawing the sun. We have this protective layer, which I'm going to do in... I'm going to do it in darker blue. This protective layer is our atmosphere, right? All of the gases on the Earth are contained in this protective shield, right? This is our ozone layer, and underneath all of this is our atmosphere. Right? The radiation from the sun's rays, as they approach, hit the ozone layer. If they want to reach down into Earth, they have to pass through the ozone layer. The whole point of the ozone layer is to take some of that energy, 100 sun energy, and deflect some of it away, which means that only some of it comes onto the planet. Right, let's say... Right, and this energy that has arrived will then heat up the planet and bounce away, leaving. Right, some of it gets trapped and bounces back, but there's this pattern of some of it stays, some of it bounces away and leaves, but some of it keeps bouncing. So from our 60 that we start with that comes in, maybe 10 leaves every time. So we get 50 bouncing back, 40 bouncing back, 30 bouncing back. Until eventually there's none left and another beam of sunlight comes in. Alright, let's run this down. Right. The sun rays are bouncing off the water. Right, they're bouncing off of the water, they're bouncing off of the land, they're bouncing off of pretty much everything. The things on the planet, the water, the ice, the land, absorbs some of the energy, but a lot of it gets bounced around in the atmosphere. When the ozone layer got depleted, right? As the ozone layer gets more and more depleted, less energy gets bounced away. So as the ozone layer gets damaged more and more, instead of 40 sun energy being bounced away, what if it's only 20? Right? Because there's less ozone to bounce some of that back. That means 80 of this got through. A whole 20 more than last time. And again, if we keep our bounce back and forth, it's going to be 70 comes back, 60 comes back. Right? We have a whole extra 20 energy that we didn't have before. And that's going to heat up the temperature of the planet. Let's put our thermometer here. Right? That's going to heat up the temperature of the planet because there's more sunlight, there's more sun energy coming in and raising that temperature. When the ozone layer is completely gone, there won't be anything that gets bounced away. We're going to have all of the energy from the sun entering the planet. So it's just going to be a perfect 100 energy coming in, which is going to raise the temperature even more. On top of that, we have the greenhouse gases. The greenhouse gases are our carbon dioxide. Oh no, my worth. Those are our carbon dioxide and other gases from pollutants and such that fill the atmosphere. And so my atmosphere is full of CO2. And so when the energy gets in, right, without the ozone, nothing stops the energy from coming in. But what the carbon dioxide does, and what it creates the greenhouse effect, is that when this energy tries to bounce away, it gets trapped and just bounces right back. So instead of having some energy leave, we get it all trapped, bouncing around in our atmosphere, off of our water, off of our land, getting absorbed into the planet, which raises the temperature even more. Right? And so the combination of having no ozone and having lots of CO2 is making sure that the energy from the sun gets to Earth and stays on Earth. And that it gets absorbed because it can't go anywhere else. There's no vent for this heat to leave. And so it gets trapped, raising the temperature of the planet, giving us the greenhouse effect that we are so used to. Water pollution is a whole other story, and we're going to talk about water pollution tomorrow. On Monday. We're going to talk more about water pollution in our next lesson, and that should wrap us up from this ecology unit. Right? I am going to transition us into tutoring and office hours. If you have any questions, comments, or concerns, or want to talk about anything, come to office hours. Check Google Classroom for the link. Have a fantastic day.